Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Arif bin Abdul Rahman, and I will present about introduction and problem statement. So for the introduction, Melford Rail Bridge with a length of 40 meters and a height of 5 meters is the bridge for our project. It is located in Chicago, Milwaukee, St. Paul and Pacific Railway. The Minnesota Central Railway began building an 82-mile railway between Owatonna, Minnesota and St. Paul, Minnesota in 1864. On this road, this huge Pony Truss Bridge is the only crossing of the Street River, as opposed to 9 structures on a similar path. The bridge is currently made of huge S-panel reverted Warren Pony Truss. The bridge is supported by concrete substructure. The goal of this study is to determine the bridge determinacy and truss deflection. Because of its recent design, the author considered this bridge to be locally notable. Going through to the problem statement, a truss is a structure constructed of straight, narrow bars that are linked together to form a triangle pattern. Trusses are typically built to transmit forces across quite long distances. Bridge trusses and roof trusses are two common types of trusses. Thus, for this project, the internal forces of the truss and the truss deflection were estimated using both a manual calculation method and LinPro software. Both below are the picture of the bridge.
My name is Kevin Chatisian, and I'll start presenting calculation part 1. This is the design of our bridge. Each joint is labeled as A, B, C, D, E, H, I, J, K, L, M, N, O, and P. Thus, we added pin support at A and roller support at I. This is the dimension of bridge. In this truss bridge, each length of the section is 10 m, the length of the subsection is 5 m, and the total length is 40 m. The height of the truss bridge is 5 m. This is the layout of the bridge through LinPro. There are total number of 29 of the members and total number of 16 of the joints. This is the dimension of I-beam. The serial size of I-beam that we're using is 610 mm times 178 mm times 92 mm. The area of the section is 117 cm squared, or 0.0117 m squared. Determinacy of structure. The number of the joints J is 16, the number of the members M is 29, the total reaction forces R is 3. By using the formula M plus R equal to 2J and substitute the value into the formula, we can get 32 equal to 32. So from the calculation, we can conclude that the structure is statically determinate and stable.
Hi, my name is Chua Wang Seng. Now I want to present the calculation part in this project. First and foremost, we need to determine the truss weight in each joint of the bridge. In this project, we assume one member of truss weight is equal to 0.904 kN according to the universal beam resources in the internet. For the truss weight of the up-top joint, which from a joint P to joint J, the truss weight is equal to 0.775 kN. How do we get this answer? Is equal to 0.904 kN times 6 member divided by 7, and we get the answer is 0.775 kN. For the truss weight of side joint A and I is equal to 0.904 kN times the member divided by 2 joints A and I plus 0.904, which this is equal to the truss of the AP or JI. Then we can get the answer is 4.52 kN. For the joint with 3 members of truss weight like C, E, G, as you can see, they have 3 members of truss. So it's very simple. It's equal to 0.904 kN times 3 members. So we get the answer is 2.712 kN. Next, we need to calculate the reaction force of the beam and roller support. We assume cross Y is positive, Mnet equal to 0, 1.679 is equal to 0.775 plus 0.904 times the 5 meter of resistance plus 3.487, which is the 0.775 plus 2.712 times 10 meter, and we do the calculation in the same way. Then we can get the VI, the vertical force of VI, is equal to 13.11 kN, and the force is outward. Then we assume outward is positive and Y equal to 0. VA minus 1.679 times 4 minus 3.487 times 3 minus 4.52 times 2 plus 13.11 equal to 0. The vertical force of VA is equal to 13.11 kN, and the force is acting outward. Next is come to an important step. We need to balance the force by using the alternative method. By using this method, we will get all the internal force of each member, and the force will be assist in the tension or the contractions. As you can see in this truss bridge, all the members is already balanced. So for me, thank you.
My name is Yong Dibo, and I will present the friction force of the structure. So the first step is we have to apply the 1 kN unit root on the point E. After that, we have assumed the clockwise moment is a positive and the outward force is a positive. And next, we have to calculate the reaction force at the support I and the A. So the result of reaction at the both support is 0.5 kN with the positive force. And this visual is show the complete equilibrium force and each member with using the alternative method. And this table will show the member length, force, visual force, and sum of a FUL, which is length times force times visual force. After the calculations, we use the formula total of a FUL divided by AE. A is the I-beam of area, which is 0.0117 m squared, and E is the I-beam of the modulus, which is 200 GPa. After we use the formula, we can find out the answer with 7.132 power of -7 m, which is a downward force. And this visual show the design bridge with apply the real force with the calculations by the Rim Pro. And this visual show the reaction force which calculated by the Rim Pro with 13.11 kN on the each support. And this visual is show the structural design bridge of internal force member diagram, and the structural design bridge is also calculated by the Rim Pro. In the table, it shows the member manual calculation force, Rim Pro software analysis force difference, and the percentage area on each member. From the table, we can analyze the range for the difference of internal force by manual calculation, and Rim Pro software was around 0.004 kN to 0.14 kN, and the percentage error calculated was around 0.13% to 6.16%. And this visual is show the deflections with 0.000000 with calculations by Rim Pro. And this table will show the compressions of calculation deflection between manual and Rim Pro software. So this table show the root, manual calculations deflections, Rim Pro analysis deflection difference, and percentage error. From the table, we can analyze the result of manual calculation deflection is 7.13 power -7 meter. However, the result deflection was calculated by Rim Pro is 8.53 power -7 meter. After that, we can analyze the result deflection of structure between manual and Rim Pro software is 0.14 power -7 meter, and the percentage error was 16.41%. And this is all about our calculations for the design bridge. Thank you.
Selamat sejahtera. My name is Tony Shantin. I will explain about the discussion and summary part of our bridge project. The design of our bridge is 40 meter in length, 10 meter cross section with 5 meter subsection. It has 29 members with 16 joints, and by using the M plus R equals to Keynesian formula, we know that the structure is statically determinate and stable. After designing the bridge, we calculated the reaction forces by using equation of equilibrium, and we obtained the forces Ax equals to 0, Ay equals to 13.11 kilonewtons, and IY equals to 13.11 kilonewtons. Next, we use the virtual work method to determine the deflection of the bridge. Manual calculation provides a deflection of 7.13 times 10 to the power of -7 meter, whereas LeapPro provides an answer of 8.53 times 10 to the power of -7 meter, which ultimately gives us a percentage error of 16.41%. Overall, the design truss is safe and is able to transfer load equally. It supports its own dead load, U-load and imposed load without failure. And throughout the whole project, we designed the bridge according to Eurocode 3. And to summarize our whole project, we found that it is important to know how each member and joint works in the structure. Work delegation is crucial for the whole project process. We also learned that the function of truss and how it distributes load evenly to form a stable and strong structure. Lastly, design codes and safety considerations are important to prevent failure of structure from happening. That's all from me. Thank you.